You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. If you're in the Middle Tennessee area or will be traveling through here in early June, come out and meet us and Saran from the Code Newbie podcast as we launch Code Newbie Nashville, a local meetup for the most supportive community of programmers and people learning to code. Code Newbie has meetups in Atlanta, Austin, Dallas, Philadelphia, Washington, D.C., and now Nashville, Tennessee. For details about the meetup or future meetups, go to www.completedeveloperpodcast.com/CodeNewbieNashville or follow the link in the show notes. Welcome to another episode of Complete Developer Podcast. This week, we're talking about why your DBA hates your ORM. And for those of you that don't speak
Gibberish?
Yeah.
Like us tech people, a DBA is a database administrator, and an ORM is an object relational mapper.
No, so we're going to start off by talking about what an object relational mapper is. Then we're going to talk about the lack of abstractions for the database administrator, chatty calls and long transactions. Visibility into the actual code being used is frequently limited. The lowest common denominator, massive network calls that are not obvious, database misuse for features.
In air quotes.
Yeah, as Will and I could both go on about this one. Foreign keys and constraints. And finally, we'll hit what it all boils down to. But before we get started, Will, what have you been fighting this week?
I have been trying to get myself, I'm not sure of a good way to put this, unpainted out of a corner. There's a page, a part of the app we're working on at the office that I built it thinking that certain things would work the way that I had envisioned it, and it turns out that they don't. And I've built a whole lot of code, and I've got to tear some pretty significant chunks out and actually move it to a different page. What's effectively happening is we've got a control that renders a canvas. So it basically it's like a fake Word document in the browser. And it's talking to a service on the back end, and it talks through WebSockets. And what ends up happening, because it's ASP.NET web forms, and there's Telerik components, and there's all this other stuff going on the page, things are posting back. And when it does, it severs the WebSocket connection, and then the thing gets disconnected. And so I've been trying to fix that, and then there's been some other issues where that control doesn't work right if it's initially loaded and it's not visible. And I needed it to be invisible at first so that I can, do a pop-up and show the control when they click on certain areas, because it's different stuff in different places. And it turns out that thing doesn't really work very well. Like, you can't scroll, text goes in at weird places. It's broke all the pieces if it's not been loaded. And so I'm actually going to have to tear that whole thing down and separate that into its own page. So that's what I've been fighting. It's one of those things where you think, oh, this will totally work. This shouldn't be a problem, because why would it be a problem? And it turns out that, yeah, it doesn't work like that. It's doing some weird stuff behind the scenes, and it isn't going to happen. So that's what I'm fighting with at the moment is yanking all that stuff apart, because it's really 2 pages now, and I've got to figure out the code's all interleaved because it was supposed to be 1 page, and I've got to reuse as much of it as I can because I don't want to write it again. So that's where I am. How about you?
Well, to quote a show that we used to look like, I am happy, happy, happy.
Really?
Oh, yeah. I don't know if you saw what I pulled up in, but I have my truck back.
Yes, I did see that.
Oh, man. $700. Turns out, those of you that have been listening for a while remember when I said I had to put it in the shop. Turns out the last person to replace the brakes, which was before I bought the truck. So it had one owner, but the last person to replace the brakes did it wrong.
Awesome.
Yeah. And so I had to do a lot of work. Now, what's really funny is I went over by my uncle's place today, and we were talking because he hadn't seen my truck up close. He's seen it, but never just like stood out and talked beside it. And so he was looking at it. He's like, "Did you get new brake calipers?" I was like, "Yep." They had to replace the front brakes completely. Man. So, but I've got my truck back, and I don't know. There's just something about that. I don't say it's probably not even just that truck. It's
not
just
having to drive somebody else's vehicle.
Yes,
because it's a personal space thing. Like when it's your car, that's a space that you own, and having that taken away is a loss of space.
Exactly, and it's the smell.
Yeah.
Not that the other car smelled bad that I was borrowing, but
it didn't smell like yours.
Yeah, exactly. That was the first thing I noticed when I got in my truck after I got it back was the smell. I'm like, it smells right.
Yeah.
It was funny. It
smells like your stale back sweat.
Well, I do have leather seats, but yeah. Still, it smells right. It smells good to me.
Yeah.
But I have that. I am still working on the bubble popping app. The app itself is finished. I'm just trying to figure out how to get it published.
Yeah, that's a whole nother kettle of fish.
Yeah. I don't know if I just want to publish it right now as a mobile website, or if I want to try and get it out into the App Store. I could get it into the Google App Store pretty easily. I did find one way to do it. I know we were talking a week or two ago about me putting it out as, me borrowing time from She Who Shall Not Be Named's potential new computer after the book is published,
so that you can build it.
Yeah, so I can build it on a Mac. But did you know they have a Mac cloud? They will build your app on a Mac for you.
Huh.
Yeah.
It's nice that they do that. It stinks how they've got things set up where you have to have a Mac for that. That's just kind of obnoxious. Like the amount of vendor lock in there is really not okay. And it really takes a lot to be worse than Microsoft about that. But
yeah, well, Microsoft has been getting a lot better about things like that, though. I mean, I'm very pleased with
because if they have it open, they can overbill you for Azure. That's
oh, don't get me started on that.
I know. So I guess it's about time with that to roll the music.
Yeah, Jason, roll the music for us. This week for IoTs, I have a research project that's been going on, and I don't believe it is out for public purchase yet, but it's a technology that I found that could be useful in a project that you and I had talked about when we were talking about the talking plants and sensors in greenhouses.
Yeah.
This is the WISP, Wireless Identification and Sensing Platform. A little bit of a stretch there for a name to get that acronym, but it gets its power from radio waves, so there are no batteries.
Oh, that's interesting.
It gathers energy using an RFID reader, just a standard RFID reader, and is able to generate enough electricity to perform some low-level, low-key processes, like tracking sensor information and transmitting it. It has about the same clock speed as the processor in a Fitbit.
Okay. That's enough for...
Yeah, that's
some
enough for
sure.
Yeah, I mean, that is enough for setting up a grid of sensors in a greenhouse.
Yeah.
And having them transmit to a central hub.
Yeah, although I do wonder how well it would work in an enclosed environment like that, especially a damp environment. But, there's a lot of applications for just ag in general that could really do a lot for.
Mm-hmm. Apparently the research has been going on for a while into batteryless processing, but what's special about this is that recent developments have made the tech practical for IoT applications. Another really cool feature about it is it can be programmed wirelessly, so you can send out updates to a network of sensors. The article even mentions putting them in a person's body.
Weird.
Yeah,
that's not that's not in terms of, hey, take this sensor and
yeah.
Because if it starts like that, that's not appropriate for IoTs.
No. This is it could mean some pretty interesting progress in the field of medical technology.
Yeah.
I mean, if you think about pacemakers and defibrillators,
right? They need power, and
you have to keep those. Those batteries have a certain lifetime. And you have to go in and have surgery to have the battery replaced.
Turns out human beings don't have battery panels.
No, and so if they could use similar technology to, power something like that from,
either from, I don't know how deep radio waves are going to penetrate into human hide, but presumably if they're able to use that, they might be able to use something else.
That's what I was getting at, was it opens the door for further research into the area. And it's kind of a fascinating thing that I found that when I read it, I thought I have to share this with our listeners because it's just too cool. I mean, once this becomes a product, I'm going to, if it's affordable, get a few just to play around with, because I want to be able to program them to possibly set up things like a sensor grid in a greenhouse.
Yeah, well, that's cool.
No. So, why does your database administrator hate your object relational mapping?
Well, let's talk about what an ORM is,
all right,
what it does, because a lot of people do fairly direct database access still.
So let me tell you what my understanding of it is, and then we can get into the actual show notes, and you can tell me if I'm right, wrong, where I need correction. But as I understand it, it is an abstraction for dealing with the database so that you're not tightly coupled to the database.
That's the theory. In practice, what it ends up being is it's an abstraction around the database so that you don't have to learn SQL.
But SQL's cool, yo.
Yeah, but SQL can be painful, especially for certain kinds of operations like iteration.
Yeah, but painful is cool, right?
Not always. In fact,
okay.
Not often. But basically, the idea behind an ORM is, and this tends to be a little bit more common in strongly typed languages, where if there's a type that's in that system, it's in there when the thing's compiled, not it's generated at runtime. But the idea of it is that I can take a database object and map those columns. Like if it's out of a table, I can map the columns into an object that my application is using. So it's a way to marshal that data back and forth. So it does all the calls. It loads up the object. It handles nulls. It handles errors, all those kind of things, and makes it so that you can interact with the objects rather than dealing with the SQL directly.
It's basically someone smarter and more pedantic than you has written out all the SQL so that you can just deal with the object.
Yeah, or they frequently, well, it depends on the way it's built. A lot of them will provide a means of mapping. So like in Hibernate, you're familiar with it, in Hibernate XML
yeah,
files.
I've used it.
Yeah, it tells you how to say this object maps to this table. And here's the columns you bring back for this type and what they go to.
In Hibernate uses XML. Is there anything that uses YML?
Off the top of my head, I can't think of anything, but it wouldn't surprise me.
The more I've used it with Hexo, the more I like it.
Yeah.
I mean, I still think I like JSON better, but
yeah, YML it does it's a good configuration format, but you'll see a lot of older stuff that's XML, and you'll also see it where it's actually inline in the code. So you've got like Fluent. I know you've seen the Fluent in Hibernate stuff as well, and you know that I don't use that. I typically do, if I have to do it in Hibernate, I do XML.
Yeah, I've used the Fluent on
because I can actually find docs on it because there's two different branches. But anyway, so the idea is that it matches what's in the database to something that my app is working with. And this allows you to use object-oriented principles like inheritance. So I could take two tables and map it to one object because one of them's the base and the other's the extension.
Okay, I see where you're going.
And so those sort of things. And then when I insert one, it puts records in both tables.
I had, like I said, I thought of it as as the ideal, the abstraction to decouple that, but I hadn't thought about it as putting object-oriented.
Yeah, it's making it so that you can deal with things in an object-oriented fashion instead of a table-oriented fashion. Now, object relational mapping, you'll actually see some articles out there. Google. I'm trying to remember exactly what the title of it was, but it was effectively object relational mapping is the Vietnam War of computer science.
I can follow that.
Yeah, because it's this extended conflict with not real good boundaries, and we thought we knew why we were there initially, and then it kind of changed over time, and there was somebody that's expressing that's like, hey, look, this is a mess.
Yeah.
The other thing that they tend to do is they integrate a unit of work pattern. So like I pull a bunch of objects back from the database, like I pull a set of objects, and bear in mind this object can have a graph. So it could be like an order with all the line items. Those are two tables in the database. Yeah. It has the customer information, and it is a chunk of data. It's what they call an aggregate root. It's right. So it can pull all that back, and then you edit all those things in your code, and you say, hey, save this. And the code figures out what SQL to actually invoke
to write it back to the database.
Right. And so that's what they call a unit of work pattern, because it either all goes or it doesn't. It's a transaction effectively, but it's a little bit more complicated.
I would think that this would have a lot of good ways to protect against like SQL injection.
Yes. It's because you're talking to the objects. So the underlying code knows that, hey, if I see a single quote, I don't want to emit that raw into the SQL because that's going to be a problem. Mm-hmm. And so it does protect against that. It also just protects against people not wanting to know SQL. There's a lot of developers that don't understand SQL. They don't do well with it for whatever reason. And a lot of it really comes out of people with procedural language backgrounds or, actually even object-oriented, because you think about, okay, well, how am I going to change everything in a list? I'm going to loop through the list, right? Well, that's not what you do in SQL. You take a set. It's a set operation for the whole group, and it's a very different way of thinking about it. So you're basically it's like switching alternating current to direct current. Some people just some motors can't take that, right?
Well, that makes
like
sense.
Any of them.
Yeah. Well, it's a different mindset, and some people are better at switching mindsets.
Yeah, and being able to switch it quickly is what gets you too. Because like if I work in SQL for a couple hours, it takes me a minute to get back into C# because I'm having to think completely differently.
That makes perfect sense. I can see why ORMs are a benefit in this.
Yeah. Now, and these are things that a lot of us like to use. Like I wrote my own ORM, right? Mine is very lightweight. It's not structured like these that bring back a complete graph, like a complete object graph. It's like, I bring back a stored proc, the results of that for a particular operation versus a thing of I'm going to join these tables and I'm going to bring this whole graph back. Mine is very structured around the database structure, not around me trying to fake an object structure, if that makes sense. A lot of folks really like their ORMs because it does make coding easier because you can stay in one environment. I don't have to switch from Visual Studio to SQL. I don't have to, jump out there to MySQL. I don't have to, whatever context. Now, languages like JavaScript and Ruby, something comes back from the database, I can just access it. Right?
They're more dynamic languages, though.
Right. I don't have to have an object that already exists and then know how to move things from one object type to another and be able to do that in a performant manner. So, dynamic languages typically don't have as much ORM culture there. They still have them.
Well, they don't need it as much because you can manipulate the objects.
Well, they do different things with it. Like if you actually look at the way Ruby does, they'll do things like where they've got, they do special method missing implementations for, where clauses, and it'll build that up with Ruby code. And so they can actually do a lot of things that we can't. It's just the fact that they don't have to do those things necessarily, that there's not as much of a culture shock there.
Okay.
So these things are very, very helpful. However, database administrators don't like ORMs on average because of problems. And so we're going to go over some of these and why they're a problem. And these are things that you just need to bear in mind when you're talking to a DBA, because these are the concerns that they're probably not going to vocalize to you, but these are the things that they've run into, and this is why they don't like this. Because if you can deal with these concerns, you may be able to sell them on the idea of using an ORM.
Yeah, that makes perfect sense. It's a psychology thing, because it's a logic thing too, because in a debate, you want to address the objections in your statement
beforehand.
Beforehand, so that kind of pulls the rug out from under any objections they have, because you've already addressed them.
Yeah.
And it doesn't look like you're being defensive by addressing them. It looks like you're being proactive.
Yeah, it looks like you're being thoughtful. And the first of these is the lack of abstraction for the DBA. And where this comes in at, and this seems like this is really bad on the Microsoft stack. I really hope it's not as bad in other places, but I kind of know that it is. I'm hoping that there is a theoretical place where this isn't such a problem. A lot of the ORMs directly access tables in the database. And so what they'll do is, like, you can pull things back and you can join and you can filter. You can either do like MapReduce, or you pull back lists and you join them. Well, that sounds great when you're building an app real quick. But when you're maintaining it over time, and let's say that, okay, we've got a data warehousing strategy, we've got audit trails, we've got all these things that we've got to do to say, hey, they access this thing, right? We've got concurrency issues.
The ORM doesn't always follow the model that.
Right. Well, and you can do a lot of things with triggers, and you can do a lot of things with access permissions. But the problem is let's say that your ORM is hitting a table, right? And the DBA at some point realizes that, hey, we've got transactions hitting this table. Like, we've got a lot of writes happening. Your code happens to be doing a lot of reads, a whole lot of queries, right? Well, those two things don't match. The concerns don't match, because what ends up happening is that so that the reads are fast, you have to put a whole bunch of indexes on the table. Mm-hmm. So that the writes are fast, you need fewer indexes. Now it's at odds, and guess what you have to do to fix it? Because you just deeply tied probably a page or multiple pages in your app to a table in the database. The DBA can't do anything about that. Because
it's an optimization problem for them, and they get the blame for it too, I would assume.
Well, because your stuff is deeply reading from that table, and some other schmuck out here who's writing to it has also deeply tied his stuff to the table. So now he's got two people who are completely at odds, but they're going through him.
And it's, who do you give the priority to?
Yeah.
Okay, I see.
And so
where this can become a major headache
problem. Yes. Now, if it's reading from a view, what can he do? Well, he can make a view that reads from some other table. So like when the transactions come in, he could say, hey, they're not going to need it within 10 minutes because it's a billing statement. We can fill this other table that we're reporting off of overnight in a batch. We'll put this thing in a view. He can hit the view for reads, and we don't care.
I see where you're going with. Yeah.
You're giving him room to maneuver.
Yeah.
But most ORMs are very table-centric. And that's a significant problem that I've run into everywhere.
That seems to be where the idea of abstracting away from the actual database falls apart, because the whole view model there would be...
Well, it's easiest to generate this kind of code. And so that's what everybody does first.
Yeah, but I mean, just saying the concept of an ORM, though, as an abstraction that pulls away from, tightly coupling to the database. If it's writing, if it's very tied into the tables, that's not really very much decoupling there.
Yeah, well, and a lot of them will support, they'll support views, or they'll support doing things where you can remap it. Like in Hibernate does that. Mm-hmm. I could say, hey, this type is mapped to this table, but then later I could switch it out and say, make this point at this view. But there's another problem that comes in here, because if I start out architecturally and I say I'm mapping to a view, you typically don't write to a view, right? You have a read model and you have a write model. Mm-hmm. Whereas if you're connected to a table, it's read write, because you can do both. It doesn't force your architecture apart, and so this can cause pretty deep structural problems where you can't fix your code, the other guy can't fix his code, and SQL Server licenses are like $40,000 per transistor or something. And they're not really that. They're pretty high, though. And so now the DBA is having to go and ask for large amounts more money to tune the system, and he's not the one that screwed it up.
It's
awful for the DBA. And there's, by the time that this has happened, let's talk about, the fact that it's probably a pretty major cornerstone of the business by the time that it's here on modern hardware.
Say by the time it gets to that point,
you can't
that
get
it's
out.
Noticed. Yeah.
Yeah, you're in the antlion's den by then. You've fallen all the way down. The other thing is a lot of the ORMs tend to not do as good of a job as far as talking to things like views, stored procedures, functions, the outputs of those. And then there's all the weird bits, like user-defined structures in the database. Things like in SQL, where you got a synonym out to another database. That's like, hey, we're going to call it this, but it really means this other thing from this other database, and just query through. Most of them fall down flat. Most migration tools do as well, especially with synonyms. We've not found one that works well at work yet. But what ends up happening is those are second-class citizens. Well, then what happens? Well, the developer that's using the ORM is like, I just want to access the table. I don't want to do the view thing, or I don't want to get an output from a stored procedure because it's harder to map because they don't get good metadata back about the stored procs, and they haven't done the effort, because you can do it. I have. Mm-hmm. It's a pain, but you've got to do that to have those constructs in place.
It's possible, says the guy that goes through obfuscated JavaScript.
Yeah. Well, I expect a $1 billion company to be able to pony up and do this properly. But that said, all these types tend to be things that are second-class citizens, and as a result, there's a resistance on the part of the developer to actually use these because of the pain that they cause them. So they'd rather push the pain back on the DBA. So they blame the ORM instead of the developer. Point 2 is chatty calls and long transactions.
So most ORMs hide the SQL that they generate?
Yes. And a lot of them hide it rather deeply. I've had a lot of problems with Entity Framework, especially creating SQL that, like you can see it when you put a profiler on SQL, which, by the way, chews through resources too. And like when you already have a production box that's hurting, that's really not where you want to be.
Yeah.
Let's make the patient sicker so that we can see what's killing them. It's not a real good plan.
Like a last resort kind of plan there.
Yeah. So it's very easy to get code that makes a lot of small calls to the database instead of a single large one, because somebody's dealing with a list, right? And they're doing it iteratively. So they go, hey, take item 1, update this thing, save it. Take item 2, update this thing, save it.
We were talking...
because they're thinking in terms of function calls, not network calls.
Yeah. I was thinking about that. We were talking a couple of weeks ago, and this reminds me about what we were saying about kind of holding the transaction open.
Yeah. Well, let's talk about, like, let's say you have an order, right, that's coming through. It's got a header, and then it's got all the line items, and then all the tax information. A lot of these systems, it goes, okay, I'm going to create the order record. That's the first thing. Because to create all these other pieces, I've got to have the ID. So what do? I create the order, and then I've got to wait for that ID to come back, and then I got to start creating the line items. And because I'm a bad coder, I'm going to loop, calling and sending those one at a time. The entire time, you have 2 options. One option is to keep the transaction open the entire time, which puts load on the database server, making things much worse. Or I can open a transaction for each thing, and potentially some of them will fail, and I'll lose data.
Oh man, I see where that.
Whereas the other option is hey, I've got a stored proc. I pass the header, and I pass basically a database table, user-defined object that's all the stuff, and then the stored proc handles it in one transaction scope. And then I don't have the back and forth. I don't have the long connection. It's like just long enough to get that data over there, and then I'll let go. Because what will happen is if you have a bunch of long-running transactions, they will lock resources in the database. Like if you're updating a record, you don't want to be reading it right now. It's something that's, like let's say you have an airline booking system and you've got a certain number of seats on the plane. Somebody's buying tickets right now. You don't want it to be like, okay, we have a guy that's in the process of buying a block of 30 tickets because he's, got a kids group that's flying to Japan or something. And you're in the process of trying to buy a ticket, but you're further behind him. How do you handle that concurrency? With airline booking, we know what happens because we've all been to the airport and seen that they overbook. And this is part of the reason. Part of it's just greed. But, these kind of things can happen. And when you're holding that transaction open, you're making it more likely that they do. There's a business cost. So yeah, that's what these do. Now, the other thing with long transactions that can happen is that they can lock things up where you get deadlocks, where, there's a process that does A and then B, and there's a process that does C and D, but C is dependent on A being done, or is dependent on B being done, and B is dependent on, like they're cross dependent, and they basically get tangled up, and neither of them can ever finish. And that's really hard to detect. Like, it will eventually detect it, and then it'll fail one of them. But it's because a lot of times you're keeping things open too long.
That makes sense. I can see how that...
Now, let's say that this happens on Black Friday with the checkout process.
Oh, man.
Okay, and you have other systems that are doing order processing and that are trying to figure out, okay, what do we ship? When do we do this? When do we do that? And you start getting deadlocks and you have long transactions happening. Now you have a cascading failure condition. Like, this is singularly awful. This is what DBAs deal with that programmers do to them.
Remind me never to take a job as a DBA.
And, oh, by the way, guess where the programmer is when this happens?
On vacation?
At the store buying stuff.
Like I said, on vacation.
Yeah, they're not in the office. Like, the DBA catches this.
Yeah.
Okay, so that's bad enough. Now, another thing that happens is visibility into the actual code being used is kind of limited because, again, it's being generated at runtime. Some tools will have a thing where you can say, oh, yeah, show the SQL, right? But what does it do with the SQL? Well, it dumps it. It's going to dump it to a log somewhere, maybe, or it's probably not going to be turned on, and it's going to take a recompile and a redeploy to turn it on, or it's going to be in some weird obscure location, or it's going to dump it out to a system console that you're not hooked up to. Those kind of things, because this is the sort of thing that happens in triage situations. You're not thinking about about this happening. I guess the best way to describe this is if the DBA goes, what code is executing when this page opens? And your answer starts out with, well, we've got to open a SQL profiler. Then you have a problem because now you're putting a whole lot of other steps on this person to diagnose this problem. A lot of times the code that gets generated is also very dense and hard to read.
Well, yeah, that makes sense.
Like you'll see a lot of, if you do profiler stuff, you'll see a lot of things too where they take shortcuts in the code and the way they generate it. So you'll have a where clause that says where 1 equals 1 and the actual filter criteria, because nobody wants to deal with a situation where there's not an and in front. And so they just go, well, if I put 1 equals 1, then everything after that could be and this and that, and it could be the predicate or it could be the join clause and the predicate.
Yeah.
So you'll see stuff like that. You'll also see use of parentheses that would make somebody who programs in Lisp cry, because every clause will have that around it, and there'll be a lot more of them than there need to be. It'll also be jammed together on one line because they don't care. Nobody's looking at it except the DBA that happens to be stuck in the office on Black Friday when everything goes down
or on call.
Yeah. And so the visibility into the code is a very, very serious issue. The other thing is that, like, if you can't get to that SQL quickly, you got to bear in mind that this thing is probably, if it's having especially a performance problem, it's happening when it's under load and it's critical. Because if it's under load and it's not critical, people don't run around screaming. It's like, you can take care of this Monday. You can take care of it when it's not. Like, if they need it real soon because things are starting to fall over. And the database, a lot of places tend to use those as communication mechanisms instead of just storage. And so when things fall over, it's like all the things fall over. Like you just touched the first domino. Point number 4. ORMs tend to be the lowest common denominator of SQL that you will find. And
so they're typically built to abstract databases and
all the databases, because we want to handle every platform, right?
Yeah.
Because
that's something I was listening to today in one of the podcasts I was listening to. They were talking about, I think it's React, forcing you to write to the platform.
Yeah.
Because
we went speed.
We went through this thing of write it once, it runs on everything. But the problem you run into is...
You write it once and it walks on everything.
Yes.
Including your free time when it doesn't quite work.
Mm-hmm. And I would think with databases, this would make them, with the ORMs, it would make them much less efficient with any specific database because they're trying to be able to work on everything.
Yeah. Well, like for instance, if they're mapping a stored procedure, let's say. You could have a stored procedure that takes one record at a time, or you could have one that takes a table, a big chunk of stuff, and processes all that as a set. The latter is more efficient in certain environments. However, the ORM is going to go, hey, I don't know anything about table valued parameters because I need to support 47 different database flavors. In fact, it's probably going to say I don't know anything about stored procedures either. That's one of the reasons they default to tables, is that's something that's kind of known, and there's ANSI standards for that, for actually getting that data out. So that's the first thing they work on. And then they might get around to the other parts. But even then, they still have to try to build it where it's one unified interface calling a whole bunch of different drivers.
So basically, the table is the level that they can get out an MVP, minimum viable product.
Yep, it's their minimum viable product. It's also their I don't know exactly what the term would be. It's the minimum viable cross-platform product as well. Once they get it,
MVCP.
Yeah, something along those lines. I'm sure there's some better marketing acronym, but basically it's the idea that, hey, I can run this on SQL. I can run it on SQLite. I can run it on MySQL, Postgres, whatever. And I know that I can get a table back. And so that's why they do it. But the problem is SQL, like for instance, SQL Server's got loads of optimizations around particular ways of doing things. But a lot of those things don't mesh with the way that ORMs talk to it.
Because the ORM has to be able to talk to everybody.
Yeah. Well, you think about it, like if you can speak English at a high level, right? I mean, we're on a podcast talking. What if you had to be able to talk to anybody on the planet? How would you do it? You would have real short sentences with like 8 words, because you're having to cater to everybody, and that doesn't work because you don't have time to learn it. It's a very similar problem. And so being the lowest common denominator, you have performance problems. This can mean not just using suboptimal calls, but having to use them, like calling things in a loop. And oh, by the way, you still need to keep this in a transaction. So you're going to have chatty calls, long transactions, no bueno. A lot of the basic SQL constructs are vastly different across databases. So when the system is building SQL, every driver has got to be able to sit there and go, okay, how do I do this operation in the most efficient manner on this particular database? Because some of them will handle, iterative type stuff. I think Oracle is a little bit better about that than SQL is.
I don't have any experience with Oracle.
I've got very little, and it wasn't real positive. And that was actually due to a lack of having a DBA. But what ends up happening is each driver has to implement it separately, which means that the model coming into each of those has to be abstracted enough where they can do it. So now you have performance problems at the client because it's got to figure out what the heck it's doing and get it into this universal format that the driver can then deal with. Or you have coupling between the driver and the ORM, and that's a problem too.
It's turtles all the way down, man.
Yeah, it really is. Another thing that happens is you have a lot of types that won't even be available. For instance, I think in Hibernate doesn't support hierarchy IDs, right? That's a huge thing in SQL, is to be able to say, hey, this is this node in a tree effectively. And you have to do some real hacky things to simulate that within Hibernate. For the longest time, things like Entity Framework didn't support geospatial stuff. You had to go, I'm going to turn this into I think it was like a double or something, and then I'm going to try to deserialize it into a geospatial type on the other end because, hey, .NET supports it, SQL supports it, but it's talking through EF, which doesn't. So I've got to turn it into a different, and you have to do all these weird type coercions, and you have a potential for error.
I mean, do they
did it. I mean, they moved it over eventually, but
I'm just wondering, do they have ORMs that are like platform specific?
Mine is.
Well, yeah.
Mine is written for SQL Server. Real SQL, not SQLite, not SQL CE. It runs on SQL. That's it. And it's because of these kind of effects. Now, the next thing is it's very easy to get massive network calls. And what I mean by this is that the ORM a lot of times will make it less obvious when you're making a network call. And I'll give you the example of an order with line items, right? I pull an order back. And typically what these things will do is they give you an object that looks like your object, but it's actually inherited from it. And there's a lot of reasons they have to do that. One reason they do it is so that they can actually tell when something's changed, because they insert code in there. And that way they can track the log and tell what's changed, right? So they give you your object back. You're like, great, I've got an order. What's the total cost of all these line items? Well, if your ORM is not too swift or you're not, what ends up happening is you go, okay, I want the total cost of the line items, right? Well, do you have that in memory or not? Do you know? Is it in that object, or is that list of line items a proxy that says, hey, when I'm accessed, go out and call and get those?
Oh.
Now do this in a loop. Now do this in a loop where each item has children. Do you see the potential for like crazy network traffic that you never knew was going to happen because you think you're accessing an object?
Yeah. That's the problem with treating the database like an object.
Yeah. It's an abstraction that leaks. They all leak. And this one leaks pretty bad.
I would think, though, that this would not be something that would be as big in dynamic languages.
Yeah, it will be. It will be just as bad because if the data doesn't come back, you don't have the data. Dynamic languages can actually be a bit worse for this because you can, if you're building the ORM, it's very easy to make that proxy. You don't have to do like runtime code generation. It's just like, I'll just stick a property on here and, here's the function that actually is.
Oh, okay. I see what.
Yeah, and so I've seen this take systems down, especially with deep object hierarchies.
Yeah.
Because it's like we're going through, we're processing, and we may even be building something up so that we have that cached as a document, so that all the pieces are in one place, so that we don't do this, and we end up doing it, trying to avoid that because we're not paying attention, and there's no way to really tell if that object is loaded. Because I give you an order object that I loaded from this method that has all the things, and it pulled back the whole object graph. But then I also give you an object that, again, there's no chain of custody on it. So you just got this type and it doesn't have the things loaded, and you try to loop through it and it's making network calls that you don't know about.
Chain of responsibility, getting into the design patterns.
Yeah, well, this was chain of custody. So this is
custody.
This is more like getting into felony offenses.
Well, yeah, but
whatever works.
Yeah, whatever works. But yeah, I mean, it's something that when you're not careful can happen.
Yeah. Another thing that comes down is some of the ORMs, especially when trivially implemented, what happens is like you edit an object, right? You change a field and it says, hey, this field was changed. Write it to the log of crap to commit.
Okay.
That sounds great. But let's say that you've got that object and you're pulling it out of the ORM, but because you don't want your ORM to be bound to your user interface, you're taking that object and you're transferring its contents into a data transfer object. User interface, you edit and you put it back, right?
If I follow you so far.
You don't want to write repetitive code, so you use a tool that maps one to the other.
Okay.
This is, take all the properties off this, write them to this. You only change one property and it has 82 properties.
Now you have to write all 82 properties.
Right. Or let's say that you do it 3 or 4 times during the course of a process that's going on.
Yeah, this reminds me of when we were setting up your site for Hexo. With Hexo, I was worried that every time you generated, because I hadn't looked deep into the Hexo code, and I didn't know if every time you generated, it generated everything again or just the new stuff.
Yeah, and it's that kind of problem. And bear in mind that when it does this, if, like, let's say if it's a naive ORM, like most of them have they've figured out ways to not have this problem now as much, but especially when it's early, like this is a mistake people make early, all those things are going to be committed as one transaction. So you can imagine what this does as far as making chatty transactions. Now, the other thing is that this will all happen in one big chunk. So now you've got this massive wad of data going across the network too. And nothing happens until that's all over there. So you can start having performance bottlenecks at either end because of that, if it's not very carefully implemented. And as a developer, you don't know because it's under the hood. And this can cause cascading failures, which pretty much any of these can. This is why DBAs get mad.
Now comes the one where I might speak up a little bit more, but databases can be misused for features.
Yeah, in quotes. And the big one is search.
I know.
Is like, let's just make it where we can arbitrarily search anything. And that sounds really good on paper until you get under load. And you either don't have indexes on things, or you have to put indexes on things that need to be able to be written to quickly.
Mm-hmm. Yes, exactly. And
Because the DBA really wants to be able to say, hey, look, they're querying on these 5 fields out of 20 or whatever that are in the table. We'll put indexes on these, but we won't put indexes on the others.
Yeah, because we
won't allow them to be queried on either, because it'll slow everything down.
Yeah. The ORM makes it easier for the developer to act as if the production transactional database is a data warehouse.
Yes.
Yeah.
And that's like literally every system I've ever worked on has had this problem at some level or another. The one I'm working on now, like the developers understand that because we don't have a DBA.
Oh yeah.
Everybody gets hit with it if it's a problem. And so we have a very keen understanding, but when you have a DBA that's the problem that's in his corner, you're not going to know.
Who gets the call middle of the night?
Not me so far. But fingers crossed.
Yeah.
But it's also very easy, like if you have lazy loading of objects from an aggregate route, to kind of do the same thing where you're like, oh, I'm going to pull back an order and all the line items. Well, again, like we talked about the select n+1 problem, as features get added to a page, like, oh, we need to handle this, and people just tack it on. And instead of changing that query that says, hey, get me all the things, it just builds up into this snowball effect of junk, basically.
Yeah.
And it's feature creep, and you don't know it till you get hit.
Mm-hmm. And next is foreign keys and constraints. And ORMs make it easier for front-end developers to ignore the need for proper constraints between database tables, as they can enforce it in code. This works until someone else edits the data.
Or somebody screws up.
Yeah.
So this is how you end up with things like, oh, hey, we're not going to make a constraint between order details and the order that they're in. And so, somebody inserts some order details because they screwed up, or because a transaction failed, or because somebody stuck a null in somewhere. And now we have order details floating loose in the system. We don't know where to ship them. We allocated the things. We may have used materials to build those items, but we don't know where they're going now.
This also, ties back to that ORMs tend to abstract things at the table level.
Yes.
Which means that it is very easy to generate select n+1 problems.
Right, where you're selecting down an object graph, basically the same kind of thing, and you're basically drilling down instead of going, hey, just give me the whole tree. You're going, let me count each branch with a network call.
Yeah.
And the way that these deal with foreign key constraints is they typically go, oh, I'm going to put a collection here and handle it, and you don't have to worry about how that data is retrieved. And it's especially bad with the constraint issue, because if those constraints are not in the database, you can get all kinds of weird problems. And especially with data where someone has edited something elsewhere, because hey, there's no constraint in the database keeping me from doing it. Mm-hmm. But then your system gets something back that makes it fall over dead because it wasn't expecting it. And if you're that sloppy, you probably didn't write error handling code either.
Well, if you're that sloppy, then
you're in that much of a hurry. Like seriously,
if you're that sloppy or in that much of a hurry, then Bobby Tables.
Yeah. Well, here's the thing with the. Oh man, that joke never gets old. No. But if you're using ORM and you're saying, I don't need foreign key constraints, I immediately classify you as a junior dev at best. I don't care if you got 30 years. Unless you have a very, very good reason, you're a bad person for doing that. Now, I can understand it in a reporting database a little bit because, we're doing a lot of reads and, it may not matter because all the data's, denormalized. But if you're ever having to jump between tables and that's not there, you've got a problem. And that's most of the time sloppy workmanship. There's some scaling things that, you might have to do that, but most of the time, that's not what you got going on.
So what does this all boil down to?
It boils down to ownership. The database does not belong to your app, period. Even if it's the only app that's using it, at some point someone else will, because they can talk to it through the same interface. It's going to happen if it's at all useful. And the best way to think about your database is not, hey, this is the database for my app. Best way to think about it is this is a microservice for data storage that's written in SQL and is living out on the network.
A microservice that you consume.
Right. You don't own it. Now, you may be writing the other side of that thing, but for one thing, you don't want to tie it too tightly to your app because business changes. You also don't want to tie your app too tightly to it because, hey, other people are writing to it. You want a well-defined set of interfaces that you talk to it through, and that's it. If you deal with it that way, you will not get burned as much as if you go, hey, I'm just going to reach into these tables and pull data out and put data in. The second thing is you've got to watch performance characteristics on the code you write. You've got to know the ORM and how it behaves as well as you would have to know the SQL that it's generating. An ORM is not a shortcut. It's a shortcut for getting things done. It's not a shortcut for not knowing. Because it will.
If you're going to use an ORM,
yeah,
you need to know the SQL. It's like, we've talked about this before. I look up and I see a calculus book. It's like, if you're going to use calculus, you have to know the algebra behind it.
Yes.
Otherwise, it doesn't make sense.
The shortcut doesn't help.
Yeah.
The shortcut will hurt you worse.
Exactly. Yes.
And it's that sort of thing. And most people in the industry do not use ORMs to make them more efficient at writing SQL. They use it so they don't have to write SQL. And that's a very, very dangerous mistake because it's a lot like a copperhead. You're not going to know you're bitten or that there's one there until you get hit.
Yeah.
And then it's too late because the fangs are in.
Mm-hmm. Also, you must have a way to actually get at the SQL that the ORM is generating, and you need to know how to optimize it.
Right.
This plays right back into what we just said, where it's meant to, you have to use an ORM as a way to optimize programming, not as a substitute for knowing SQL.
Right. And one thing that comes up on this is when you get that SQL, like for instance, I'm going to use SQL Server as an example because that's what I use primarily. Mm-hmm. Is I can go in there and I can take a chunk of SQL and I can say, hey, show me the estimated execution plan. I can look for table seeks. In other words, where it's not looking at an index where it goes, hey, I'm going to loop through all the rows in this table to try to find what you're asking for.
Yes.
Like that you don't want that. So you have to know how to do those optimizations and be able to say, hey, is this thing going to perform under load? Because your development database is probably not as big as your production database. And it's full of junk data. The data's not, it's not got the same layout as you will have in production. So you really have to go, okay, if I do this, like, because SQL will tell you, hey, you don't have an index on this, bro. I know you only got 5 rows in this table, but there's no index. Like, that becomes real important in production. So you've got to be able to get at that. And the final one is that you always have to remember that there is a service boundary, a security boundary, and typically a network call involved when you use the ORM. You cannot treat it like it's inside of your app because it isn't.
People do that?
Oh, yeah. Lots of people do it. I've made a career cleaning up this kind of mess.
Wow.
Because it's easy to forget.
Yeah, I mean, I can see that especially if you're using the ORM as a substitute for knowledge of SQL.
Yeah.
It would be very easy to forget, but
Well, the network boundary is the least difficult thing to forget.
I guess I'm lucky having you as my mentor because you have had me.
Because I'll throw a chair at you if I catch you. No, sorry.
Yeah, well, there is that.
Oh, you're not going to put a foreign key in? Now we got to hit you. Now I got to cut you.
I will say this. I had an interview the other day, and I was explaining to the technical interviewer why I would do something, and it ended with that, and my mentor will kick me in the knee if I don't.
Yeah.
And he's like, what? And I was like, we've known each other since college. We used to do martial arts together. And he's told me, like, the way he gets me to remember things
is important.
This is important. If you ever do it, I'll kick you in the knee. Or if you don't do this, I'll kick you in the knee. And it sticks with me because I kind of chuckle and laugh, but I also know
he might.
And the technical interviewer, I mean, it was a really good interview.
So the network boundary, right? That's something people think about. But the other things that they don't think about are security boundaries. Because, hey, I'm making a call over here, like a network call might fail. Well, the fact that I have to log into the database, I have to make a connection, that could fail. My security principal may not have access to whatever I'm trying to talk to. You've got to deal with those error conditions, and people typically don't. They just go, oh, just let it blow up. And, you want to surface the errors quickly, but, that's not really optimal if something's dependent on that. And you'll also have the issue of a service boundary. And the idea here is this is a place where the concerns of your app are not the primary concerns, because you're throwing something over a wall. It's like, oh, I don't need these rocks, I'll just chuck them over the wall. That's not being a real good neighbor. And you got to bear in mind, hey, other people are using this database. I need to not do that.
Yeah, that's why you don't fire a gun directly into the air.
Yeah, because it's going to come down.
With real bullets. Yeah, the bullets are going to come down.
Yeah, and it's kind of the same principle. It's the idea that, hey, there's a set of concerns out there that's not mine. Like, my app can be slow, and that's not necessarily a good thing, but it may be an app that can kind of get away with it. But if it's causing problems across that service boundary, somewhere where something critical is, you have a problem. Mm-hmm. So that's really what all this comes down to. This is more of a social thing than it is a programming thing. It's like, don't be a jerk to the DBA.
Yeah, it really is. And understand that their job is to facilitate your code working.
Yeah. And they can't do that if you're setting them up to fail. Like, just don't set people up to fail.
Yeah, you want to
cultivate a good relationship with them and make sure that, everybody knows that
you want to be the guy.
Respected.
Yeah, I'll say you want to be the guy that the DBA says, I always like working with his code because, he writes it well. That kind of wraps us up before we close everything out. But what do you have for us for tricks of the trade?
Well, we had the whole talk about service boundaries, and so I kind of want to expound on that a little bit. When you have a piece of an application, or you got a set of connected services that form, whatever the thing is you're producing, right? You're typically not going to build just a website. At some level, there's going to be some long-running background process. There's going to be something that sends out emails, and you don't want web server threads getting eaten by that. That's a canonical, simple example, but long-running processes, batches, those kind of things are going on. They have a set of concerns for how they're supposed to perform. That's their, you may have service level agreements on, how quickly those things return data, how frequently they return data. It's also very easy when you're building these things to not care about how they impact the rest of the system, because, hey, this is the part that reflects on you. But what you're throwing over the wall into the database, you're putting in bad data that's going to cause a problem for somebody else's app. It's very easy to forget that because it doesn't directly impact you. And you sort of get this tragedy of the commons type setup when you're in a larger team, especially where a number of people have got their own services running that they're responsible for. There's a lot of people that will cut corners. I've actually seen this fairly recently where somebody was inserting garbage data into a system that I was working on and some other folks were working on. And it didn't bite me, but it bit a more junior developer. And what ended up happening is the junior developer had to build all these hacks because he was getting crap data out. When he would make a call, he was trying to keep his stuff from crashing because it made him look like a jerk. And it was somebody else throwing something over the wall. Now, he could have gone to the guy and said, hey, this data is not right. What's going on? But he didn't because, again, there's a service boundary. Like, his concerns and that guy's concerns are not the same. And they don't even know each other all that well. And that's very easy to do. Like, it's not the fault of the guy that was putting the bad data in there because, it was an honest mistake. And how would he know? You're going to eventually do this at some point. But the point is you got to be cognizant of the boundaries of what your service does and what it is supposed to do, and where you're throwing stones over the wall and hoping there's no pedestrians. But at the same time, when you're on the other side of the wall and the stones are coming over, you got to go, hey buddy, whoa. So that's what I got. If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at completedeveloperpodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.